we have air alarm just in time in our lectures to become energized a bit. Okay, we have today wonderful and important topic, which Vlad will present in a minute. So let me encourage you to jump in, to pay attention to that. And let me remind you that we have also materials in our canvas. So all next topics regarding linked list, stack, queue, algorithms, sorting, searching, is just fundamentals of algorithms, data structures. It is fundamentals for your thinking as a software engineer, as a computer scientist. This is just basics. This is what will differentiate you from people who just finished or graduated from some programming courses, you know. So this is what will differentiate you. This is what you could work with on an interview to, I don't know, any Ukrainian or international company, and including Google and Meta and so on. So this is basics of computer science and algorithmic thinking. So this is quite important stuff. This stuff, of course, is used in real life in many systems, but under the hood. So maybe we'll not so often use it by ourselves. I mean, this creating algorithms, sorting and searching, but maybe you could even use that. So, but my simple message: be attentive, stretch your mind. This is not so, maybe this is more mathematical stuff. I could say this is more thinking, more algorithmic stuff. But it is so important to love algorithms, because you're data scientists or software engineers. It is so important. Okay, without any delay, I give the mic to Vlad. So welcome, Vlad, and let listen.
Today we're going to talk about linked lists and other stuff, but we will start from linked lists. And I want to share with you my experience. When I was studying in university, we had a whole course about data structures and algorithms, and we were creating those data types with C language, and this was my favorite subject, because it's very interesting to imagine those very abstract concepts and creating them with some code. And I hope you will have same passion about data structures and algorithms as I. So let's start. What is a linked list? Linked list is a data structure used for collecting a sequence of objects that allows efficient adding and removing of elements. So what does it mean? Let's compare it with an array. So as you know, array is another data structure where we are saving some data and we can have an access to this data through indexes. And if we know the index, we can access some data. Let's imagine that this is, and arrays are stored in memory in such way, so we are reserving some part of the memory and placing data next to each other. So if we know the starting point, we can add some index, and we can have access to some data because very quickly, because all this data stored in one place. Understandable, right?
Yes.
Yeah.
Well, should be.
Yeah. Okay. So let's imagine that we have our memory, and how does linked list working? So we placing some data. For example, let's give me some ints. We placing some data, but if we want to add another data, we're not placing it next to this piece of data. We can place it anywhere in the memory, for example here. But our, let's say, node of this data have a reference to this node. And for example, this node have reference to this node. And it's working in the other direction. This node have a reference to this node, and this node have a reference to this node. Those references from the programming viewpoint, it's like a field in the class, and we will talk about it later. But you know what is reference to some objects, right? If you don't know, we can discuss it. We have such data structure where we can't have an access, instant access, for example, for short element, because to have access to this element, we need to have first element, we need to have object, second object through the what? Reference. Yeah. And we need to have short object through the reference that stored in the second object. But looks like pretty bad data structure, because in array we can have an access, for example, for short element instantly. Here we need to do some calculation, some work. But if, for example, we want to add new element and we want it to be the first one, in array we need to replace all those elements. So if you want to add element with index 0, new element, for example 6, we need to move 5 to the second index, 7 to the sorting, like to the index 2, and so on and so on. And then we can put 6 to the index 0. In linked lists, so we have huge, it's not so easy and simple, but with linked lists, we can just add a new element. We can change its reference to the our previous first one, and we can change reference for the previous element of this element to the 6. And we have such situation that we can add a new element in the beginning of the linked list with one operation. But in array, we need to do like n operations. Is this okay? Are you with me? Okay. If you have some questions, you can ask now. Yeah.
Where does the 5 go? Like after weights are 6 and 0? No, in linked list.
What?
In linked list.
So, for example, in our memory, it's not the first one, not the first cell in our memory. Like all the memory cells, they are not named like 0, 1, 3. They have a more complex address because it's there a huge amount of memory. So, like 5 is still on this place, and we can add our 6, for example, here. But we will think that this is our first element because it don't have a previous one, and it's looking for the 5, and 5 now will look the 6. So it can be everywhere. It can be like in here. It doesn't matter. As long we have, as long as we have an reference to the next one and the previous one, they can be everywhere in the memory. Yeah.
So, as if I understood correctly, they can be scattered in like 12 billion places in memory, and they still could be accessed just like by looking at what one reference to another.
Yeah. Yeah.
Is this like a linked list? It's like something similar to array of arrays, but this array is stored like everywhere.
No, because linked list it's not a node of linked list. It's not an array. It's like class that have data, but additionally it have two references to the next one and to the previous one. Or maybe
So it's like pointers.
Yeah. A reference is like pointers. So inside node we have information about place in the memory of the other of the next node and previous node.
Okay, so only two references for each node.
Yeah.
What happens if, for example, we change the previous node for another one? For example, if we have, for example, if we have, for example, 7 in like place 4, and then we add 6, for example, in place also 4, and change like.
We can't place anything in the place 4 because it's already reserved.
All right, but okay, and what if can we change like the reference to like the next object to another object, for example, like we have here, like we have the reference first it was to 7, for example, and then we changed it to 6. Like, is it possible actually? So you have written like 6, which is the reference to 5, and 5, which is the reference to 6. So what is like this reference?
Yeah. So as I said, every element have reference to the next element and to the previous. So 6 have a reference to the 5, and 5 have reference to the 6 because 6 is a previous element of 5, and 7 is second. It's a next element of 5.
Alright, so we don't right now we don't need to look at indexes at all.
Yeah. It's those indexes is just for, maybe it's confusing, but it's my way to compare it with an arrays. In linked lists, we don't have such. We have thing like index, but it's like in array. So when we using the linked lists, we can say get element by index, like with index 3, and in such an example, index 3 will be this element because it's 0, first one, second one, third one. Like we counting them, like it's like a simple count, and it's like to compare.
Alright, I see.
Yeah.
So like index is more like a label by which we can.
Yeah, like key, but.
Okay, yeah, alright.
Yeah.
Can you repeat this about indexes? Like you said that we count them, yeah, but then why our index 3 is 3?
Because 0, 1, 2, 3.
Why 6 is 0?
Because it's the first element in linked list.
Not 5.
5.
The second.
Yeah, I understood that we don't have such indexes at every
Yeah.
place. That's
5.
like for our memory, we don't have the index of memory.
Let's follow the arrow. So 0 is the element with index 0. Then 6 have reference to the 5. 5 is the element with index 1. Then 5 leads us to element 7. It's element with index 2, and then 3. Let's be
But also 5 has reference to 6.
yeah, because every element
Has
a
reference to the next and to the previous.
previous, yeah.
Okay, and can't it be the opposite way? For example, the 13 is the first one, and then we have 7, then 5, and then 6.
Yeah, in the next slides we will be so every linked list have a head and a tail.
Ah, all right, that
Yeah,
makes sense.
yeah. So we define it. It's 13. It's the last element.
Okay, and are the references like different for previous and for next? Like, are there like different, I don't know, classes or functions for the references which to the previous one and to the next one? Like, are they different?
Technically, it's the same. It's just two different fields in the class: next and previous.
Ah, okay. So like we can like differentiate the reference to the previous and to the next
Yeah,
one.
yeah.
Okay. So like it can be seen that 13, for example, doesn't have the reference to the next one.
Yeah,
Okay.
yeah. When first element in the field of previous reference, 6 have null, and
Okay.
last one in the field next have
Okay,
null.
it makes sense.
Yeah,
Alright.
yeah.
Quick question to waste time. Do we have to manually manage the memory or no? If I want to delete some part of list, do I have to do it manually, or does it? Do I have some function, some method to delete it? Is it automatically? Or
Yeah, it's automatic, and I will talk about it
Okay.
later. So let's move on. It's pretty abstract right now, but we will we will dive deeper in more like прикладной, applied way. Yeah. So I already talked about how to work with linked lists, so it's okay. Also, when right now we touched a little bit the comparison between array and linked list, so talk a little bit about big O notation. So I think some of you already know about big O. So big O, it's maybe someone will tell me what is big O notation.
Big O is the way we describe the complexity of algorithms.
Yeah.
So I guess it was like the time to calculate the time which takes the algorithm. So it can be like n if it's just for loop. So it's
I don't know.
like if two for
Please
loops,
take the
then
mic.
n squared. And I don't know like how to explain correctly. It's like some just intuitive thought and it's so.
Yeah. So big O, it's a mathematical notation about complexity of the algorithm. But the main point of big O, it shows us the worst scenario of the algorithm. So, for example, we have our array, and we have here 5 elements, right? For example, we want to find element 9. How we would do this? Like we have such thing like linear search. I know, very interesting, but let's imagine that we have an array. For example, if we want to find index of element 0, index of element 7, for example, we can do it with linear search. For such search, we need to check the first element, the second, then third, and so on, until we find our element. So in this example, to find element 7, we need to do four like computations, right? So for the linear search, big O is big O from n. That means n is the size of your array. So big O shows us the worst scenario of the search. What's the worst scenario of the linear search?
Oh, the last element.
Yeah, if our element that we're trying to find is the last one, we will do n computations, number of computations as a number of elements in our array, right? For example, if we're doing a bubble sort, who can tell me what's the big O for bubble sort? N squared, yeah, correct. Can someone tell me why it's n squared?
Because we use 2 for loops for loop and
Yeah. Yeah.
Because n squared because we use 2 for loops.
Yeah. So the reason why bubble sort is n square, it's the worst scenario of the bubble sort is that every element is not on its place, and we have 2 loops, and every loop will work n time, right? So is this understandable? Okay. Now, for example, if we want to add a new element to the index 2, for example, what the big O of this operation for the array? Or for example, at the index 0.
If you want to do get what?
Add a new element. N. Right, because we need to move every element to the next position and place new element to the position 0. And we need to do n tasks, right? But if we will imagine our linked list, for example, and this is our first element, this is our last element. Can someone tell me what will be the big O of adding a new first element?
O1, yeah.
Yeah. O1. Because what we need to do is only add a new element and connect it to the previous first element. Can someone tell me what the big O of adding of, it's funny question. What's the big O of reaching, of getting element with index 3 in the array? Like if I want to get element 7. O1, right. Because in arrays we have such data structures that we already know where this element is stored, and if we have index, we can have element instantly. But what's the big O for getting this element in linked list?
I think ON.
On, because the worst scenario is that our element is not about worst scenario. If we want to have this element, we can't get it instantly. We need to have first one, then move to second one, then move to third one, and only then move to our element. So the worst scenario is that we need to do n operations, but really it's working only with linked list with one direction, like this. So in this example, our worst scenario is that we need last element, and to get last element, we need to move n times. But if we have such linked list, and we already have first one, we know about first one and last one, I think the whole will be n поделити n
Half,
half of n, because we can check like if index of elements that we're trying to get is in this, like we can divide our array list to two parts, and if our element is closer to end, we can start from the end and move in this direction. If it's closer to the start, we can start from the head and move in this direction. So I think in this example, it would be n divided for 2. Is there any questions about this topic, about this concept?
But how we know where it is closer to what hand if we don't know where it is?
Yeah, I'm talking about getting element by index. So we think that this element has index 0, 1, 2, 3, 4.
But can we store also size?
Yeah.
That's why we know.
Yeah, thank you. Yeah, in linked list, we know the size of the linked list. So we know the size, and we can get element by index. In linked list, indexes work different from the arrays, but we using indexes also because it's comfortable to use indexes.
Okay, so we know the length, it's logical.
Yeah, and we just like dividing lengths to the index that we're trying to get. Yeah, but if we're trying to find element in linked list, it will be O from n, because as you said, we don't know where to which end closer elements that we're trying to find, because we don't know like where it is, like logically. So, yeah.
What is O and half?
O and half, n, as I said, it's the size of our, for example, list or array. So the worst scenario that for such operation we need to do size of the list divided to 2 times. So, for example, if we have 5 elements, to find 7, the worst scenario is that we need to do 5 operations. Move, check, move, check, move, check, move, check, okay. But if we're trying to get index element with index 2, it means we need only like 2 operations, because we can start from this end and from this end. And like if we're trying to get O, we can start from this, and it will be one operation, but the maximum amount of operations is 2, because it's the worst scenario that our element will be in the center of our list. It's
Okay, so it's a search from two sites.
it's not like a search. We know already index of element. It's like with array, like you writing like variable and index in the square brackets. And in situation with array, you getting this element instantly. But here you need to do some work under the hood. Like you need to move some number of times through this linked list to get data that stored in this node.
Okay, but why is it n half not n?
Because this linked list is linked in both ways. So every node know about its next node and previous node. And linked list store information about the first node and the last node. And we know the size of the linked list. And if, for example, I'm trying to find the index 2 element, I can divide my size of the linked list to this index, and I can find in which half this element is contained, and I can choose. I can start from the second element and from the last one. And the worst, O is the worst scenario, and the worst scenario is that element will be in the center. And to reach the center, I need only n half times to like move. Yeah, okay. So let's move on. In the Java, you already have implemented linked list, and you can check it in your IDE. You can check how it's working, and here an example of how we can work with this data structure. And you can see here that it's very similar to the array list. You create its generic data type, so you can write the data type of this array list or this linked list, and then you have many methods actually for working with this. But here you can see add last. But let's draw the example that we have on the screen. So we're creating new linked list. Okay, we have created an empty linked list. Then we writing add last. What does it mean? We creating a new node. Harry, and we saying this is our last element. Okay, so we don't have pointers to the next one, to the previous one, because this is our only element in this linked list. Next, we adding add first. We're writing add first. This means that we adding a new node, Sally, and we're saying this is our new first element, and we connect. We're saying Sally now is the first element. It doesn't have previous element, but it has next element. Harry now not the only element in this linked list, and it have a reference to Sally, because Sally is the previous element of Harry. Next one. We saying get first. We getting this element because it's first element. Next, get last. We getting Harry because now it's last element. Next, remove first. Remove first means that we are not deleting Sally from the memory. Actually, what we are doing is we are removing those references. So we are removing Sally from the field of previous reference of Harry. And now Sally is existed in the memory, but no one have reference to Sally. And our garbage collector that built in the Java is deleting Sally. So actually we're not doing the dirty work. We are not killing Sally, but like we throwing Sally from the boat in the open sea, and our shark garbage collector eating Sally, and we are now only with Harry. And Harry now our first element, because Harry don't have previous like element. Yeah. And next we can see an iterator. Sergey, do we need to talk about iterator?
Be nice.
Yeah? Okay. So, in Java,
Because you have your homework to create actually.
Oh my god, okay.
Okay, so let's talk about iterator. It's not very hard thing to understand. So, for example, once more, we have an linked list. It's already linked. So we have three elements. Element 8, it's our head. Element 5 is our tail. This is linked list. And we have a list iterator. So what a list iterator does is it's helping out to traverse our linked list. So linked list is data structure, and a list iterator is the instrument that helps us to get some elements from the linked list. And here you have an example of functions that contains in a list iterator. So here you can see in this section that we are creating list iterator with generic string, as we did for linked list. And inside linked list we have function list iterator. So inside our linked list, from the inside of object of our linked list, we can have object of list iterator. And what list iterator does is helping us to have elements. And for example, we have a list iterator, and we can do such operation. String s, let's it be strings, not ints. It's strings now. So we have our object of our list iterator. For example, we saying we want to call method next. What does it mean? It's that we will have our first element, and and list iterator is containing pointer like our nodes. So when we say next, okay, I have another example. It's easier to understand from such perspective. So, for example, we have a like search field, or in the Google Chrome we have a search bar, right? For example, we have here some text, and we have this blinking bar that indicates where in our text, right? So list iterator is working pretty similar in some way. So, for example, when we start and when we creating list iterator, we're saying that our, for example, every chapter in our search bar is the element of linked list. And our list iterator is this blinking spot. And for example, when we pressing next button, we moving our link indicator here. And in such way, working list iterator, it helps us to move through our linked list. And when we say next, we moving like we now here, and we have access to the next element and previous element. When we touching next button once more, we moving our blinking bar next, and the same with the linked list. And now we have an access to the next element and the previous element. Is this understandable? We can ask questions. Okay.
I guess like let's I see the material will understand further. Yeah.
Okay, so also a list iterator have many methods like has next. For example, to do next operation, we need to check is there a next element. If there not, it means we are already in the end of our linked list. What I want to say, I think you will understand this concept of list iterator. The main thing to understand it's not our linked list. It's just an instrument to traverse linked list, to move. Like you can do this moving by yourself, like having this node, looking at field of next, getting next element, but list iterator doing this hard, like not hard, but not interesting work, and very the same work, монотонну роботу за вас. So maybe someone have questions about this. Yeah.
So if we are talking about the iterator with has next or has previous, it checks if something has like the next is assigned to null or something like that, or some other indicators exist.
Yeah, great question. If our element is the last one, our field next that shows a reference to the next element will be null. So yeah, basically has next checking this field and checking if it's null. Okay, move on. In your assignment, you will face a creation of your own linked list, and now let's check this example of implementation and realization of linked list. So in the heart of the linked list is our node. So our node is this thing that we are talking about. And as you can see, it's generic method. Are you familiar with generic, not method, class? Are you familiar with generic classes?
Oh, I think that's standard.
Yeah, so it's not so hard. Like you need to declare your type that you want to use inside your class. And here you can see that our generic T is our element. In this example, it's string, me, mine, boop, and here you can see that we have references to our previous element and next one. And it's also must be an object of class node with the same generic. And we have a constructor where we can have our previous element, our element, and our next node. So, do you have questions about this class?
No, we have it like I'm just looking at this and
Is this looking familiar to you? Like this?
Structure.
Yeah. Okay.
Sorry, what's the difference? Okay, so we have a class node and it's of type
Yeah, it's generics. So this like notation means that when you're creating an object of such class, you need to write the type inside those brackets. And it's like with linked list or array list. Like you need to write the type of your element inside those brackets. And this is how it looks from the side of the class, not from the creation of the object. So yeah, you can read about this in documentation. It's called generic class. So next one, we have our linked list class, and you can see that in linked list we have the first and last elements, like here. This is our first element or head. This is our last element or tail. And linked list know about first and last one, but don't know anything about those that in the middle. And also we have size of our linked list. Is this okay? Yeah.
Could you please use the previous slide?
Yeah.
Why is it static? Because there are many nodes.
Yeah. The point is that our node is the inner class of linked list. Why static? Interesting question. I think it's because I don't know. Yeah.
So yeah, it's not so essential, but yes. So idea that if you jump into inner classes, you know that static it means that it is like should not be connected to a particular instance of parent class, and but basically yeah. So it is not so essential at this point. So we know that it is just abstract node, and we could use it inside the linked list class. This is it. So why is static? So maybe in few words, really hard to explain.
Okay.
But basically, it's the idea.
Yeah, but the main point that node is the inner class of class linked list. And then, for example, let's discuss get node method. So get node by ID in this example. So the first statement, we checking our index in the, this is what I talked about earlier. We checking if our index in the first half of the linked list or in the next half. And if it's in the first half, you can see that we starting from the first element. Here in the linked list we have field first, and we creating an object of our current element, and we assigning it to the first element. And next we are traversing our linked list. As you see, we creating a for loop, and we doing our next operation index time. So let's create some bigger linked list one more time. So, for example, let's. For example, we're trying to find element with index 2. It's this element, right? So basically, in this code, what we are doing is we are creating an for loop where we have our current element, we have this element as our current because we assigned to the current our first element, right? And then we assign to our current element the next one. So we checking in our node class, we checking our next field, and it's have type node also. So we assigning to the current our next element, next element of current, right? And we saying that now current is this element, and we once more, we assigning to the current our next element, and we having this element, and we are returning this current. So yet node returning node with the index of 2 in this example. Is this understandable? Yeah.
Is it possible to make it as a recursion somehow so it's faster? So instead of
Yeah, I think so. I do think it will be faster, but it will work with recursion, definitely.
because recursion it will be like binary search, it's faster.
You can do the binary search here because this is a linear data structure. So binary search will not work here. Yeah. Let's move on. For example, we want to add first element. What we need for this? We are creating this new node. As you see, we are writing code. We are writing new node. So we are creating this new element with some data element. For example, it's 23. Then we are checking if we have a first element in our linked list. If we don't have first element in our linked list, that means that this element will be our first element. But if we already have first element, what we are doing? We are saying that previous reference of our current first element now facing this new first element, and our new element became first element. So now we have such array list. Do you have questions about this?
I'm trying to
I think the
understand like why last is the new node, like if we write it first.
I think-
Maybe I overlooked it.
I think there an error, right?
Where last equals new node.
Yeah, because the first case when we don't have any
Oh.
elements at all, and then first and last are.
Oh, yeah,
it's,
so
it's pretty logical.
yeah, like
Yeah.
first cannot be null if we have any elements in the list. Yeah, makes sense. Okay.
Yeah.
Yeah, and if the last will stay null, it basically will just broke.
Yeah. The problem is that we moment when we are creating our new element, already in our constructor, we are setting
Yeah,
that
by the way.
it's looking to our current first element. And
What if we don't have one?
it means that it will be null.
Ah, okay, yeah.
And it's okay
it can
for
be
us.
like that, okay.
Yeah. And only in this part, we are saying that now this is our head, our first element, and our previous first element now looking on this as a previous. Is this okay? Okay. And also realization of the add method, because we can add not only in the beginning of the linked list, we also can add elements inside, in some moment, in some place inside the linked list. So what we have here, some checks to not be out of size of linked list, and then we check in our index. If we're trying to add element on the place of first element, we just call in add first. If we're trying to add to index that are equal to our size of linked list, it means we can just call add last. To not write some code, to not do explicit, to not do some computations that we don't need. And if element that we want to fit, it's not the first, not the last, then we are writing, we are doing some more interesting stuff. So what we are doing here, we saying that our current node will be a node that have such index that we want to put. For example, in our example, we have such elements. For example, we want to add element with index 3. We want to add element with index 3. It's like, okay. So we say current, this element became our current element. Next, we create a new node. We say we create a new node. Let's be 25. And we're saying that our previous element is the same as the previous of our current. So our current is 5. Its previous element is what? 7. Right. And we can copy this reference, and we can say previous element of 25 is the same that of our current element. Okay. Then we are saying our current previous next, so you can see that we are accessing our current, then we are accessing our previous, and then in the pointer of our current previous, we want to set its next pointer. And we're saying that now it must to watch the new node, this one. So we removing this connection and saying 7 now watching 7 now having 25 as its next element. It's okay?
Which exact line of the code is doing that?
Yeah. This one. Are you with me?
This is very nice to understand, this particular line of code. This is exactly what Vlad explains. But it's nice to understand. There's many references here that explode in your mind, but it is not so hard and it is really needed to understand.
Okay, so when we're like announcing the new node, we're setting up like its references, and then in the next 2 lines of code, we're setting up the references of 2 like neighbors, let's say.
Yeah.
So of the current, which is 5 there, and of the 7, which is of the previous, which is 7. Okay.
Yeah, this concept is very similar to, do you remember in bubble sort, when you swapping elements, you creating the temp variable where you store the like one of those swapping data. Here, very similar situation. You have this element, you need to swap those connections. So, is this like from 1 to 10? how this understandable to you? This what we are doing now and other class
I think yeah.
two.
Like I already I remember hearing something like that, so I like it's
About 8, but my mind is processing.
Mhm. Okay. And in this line of code, our current element of pref, we are assigning new node. So we say the previous element of 5 of our current element was element 7, but now we say that the previous element of 5 is our 25. And 25, I think, yeah, I forgot this line. When we are creating the new node, we said that the next node of 25 will be current, and this is this node. So now 25. Now our index system will change. Like it's pretty abstract. As you can see, nodes don't have index inside them because it's dynamic value, and we using this. It's like их порядок. So now we have something like this. Okay. And remove element. I wrote here another code, sorry, but how remove element works. What we are doing is we getting, for example, we want to remove element with index 5, for example. What we are doing, we saying that element 5 is now our current element. We're saying that previous element of our current is this one, and now we want to we're saying that our current ref next will be our current what? Next.
One more amazing line which you should understand. Very nice line.
If you will understand this, you understood concept of operations with linked list, I think.
okay. Let's like break it down. So
Yeah.
we have current, previous, next. Okay, so
Yeah.
like current, which is now 5. Yeah, 9.
Yeah.
Yeah, 9. Yeah, we have this the start. The current previous, so the current previous is 5, and we decided the reference for like next in
Yeah.
5 will be 7. So we like
Yeah.
reference the 7. Okay, yeah, makes sense. Because 9 is removed.
Yeah.
Okay.
And then we say that our
Our current next previous is current previous, I guess.
how
Current next previous equals to current previous. Current. Like
yeah. And what does it mean is that our next previous now looking to this, and but not to this. So now we have our element 9, our current element. It have some references to 7, to 5, but no one looking at this element. So as with Sally, some garbage collector shark will eat it at some point. And now we have such linked list. And I think it's it from me. And now we will hear something about stacks and queues from Valia. But before this, maybe someone have some questions about linked lists. Yeah.
In this example, what was our start?
No.
Like our current.
Our current was that we deleted.
And our start was
Yeah, because in this element we had an access to previous and to the next one. So we can manipulate with next of previous and previous of the next.
When we say current, this start or what is it?
Start?
I mean the word current, which it applies to which app?
To this one. To like 9 and then 11.
And current will always apply to the start of our list.
No, we need to get our current. To get our current, we can use method getNode. So we have this getNode, as you can see here. We have reference as a
So
return.
we can select.
Yeah.
Oh.
Like we can choose what element of which index we want to delete from our list, linked list. We can get references. We have get reference to this element, like in this example, and then like do this stuff and delete this element. So, if there are no other questions, thank you, and I give the floor to Valia.
Hello. Well, the worst is over. It will be easier part, I guess. And now we will talk about stacks and queues. Maybe you already know something about stacks and queues, so let's go through it. What is a stack? It is a data structure which represents a LIFO collection of objects. LIFO, last in and first out, like a stack of plates. So you put a plate on the stack, and then it will be now our first candidate to take off the stack. So here is a little GIF how it works. So we can push an element to the stack, and when we pop element, we just remove it from the end of the stack. And elements are removed in the reversed order as they were placed. So here I have, when you add ABC element, then you remove them in the order like CBA. Everything is clear? Yeah? Nice, okay. So, examples of usage. Why we need stacks? The first example is undo mechanism in editors. By the way, in Empat we now are developing a web editor, and now currently I am working on this task, an undo mechanism, to remove changes and then to get back to the changes. This is a pure stack. You understand why?
What is web editor?
So we have a project in Empat where people can download their comics and cut them to the frames. And these frames are like phone friendly, so people can then read comics from their phones in friendly format. And we are developing an editor to select these frames and to make some visual effects on them and so on. Yeah. So imagine Photoshop, you have this Ctrl-Z, it's undo mechanism. So you have a stack of actions. When you tap Ctrl-Z, you remove this last change from the stack and go to the previous state, and so on. Next, web browser navigation. I mean the back button. When you are going to the page and you tap back, so the last element is popped from the stack and you appear on the new last element. Yes. And the most important stuff is runtime stack. So do you know the site website Stack Overflow?
Yep.
Do you know why it is called like that?
Yep.
Error notes.
Yep.
Nice. So a little visualization to revise. So imagine that you had a function like main, for example, and this function calls another function like get sum. This function getSum also calls some function. Like doSum. This function also calls a function. Yeah. So, and how this works, I will take another marker. We have a call stack. And these functions are going to this stack. So first element will be main. When we are going to this point, when we need to wait and get result from this function, this method like stops working and we are going inside this function. And then we are going to this function. And then we are going to, yeah. And when this function ends, this element is removed from the stack. We go here, here, and here. That's why recursion is possible. We have a recursion function which calls itself. So we have stack like this. But the stack doesn't have the infinite size. That's why at some point, if you don't break this by some condition, we will get Stack Overflow exception. So this is a pure stack. How to realization of a stack. This realization is based on linked lists which Vlad showed us, and it is pretty simple. When you push element to the stack, you just add it to the end of a linked list. So you add an item. When you pop element from the stack, you just find the last item and remove it from the list. That's all. And you get it. Return item. Everything is clear?
So stack is a chain like
Here in this realization, this is a subclass of a linked list. But Java has its own realization of a stack, its own data structure. But your homework will be to write your own realization of linked list and stack. So basically, yes, it is a subclass.
And like a stack is basically a Python list.
Eh?
Well, kind of. Well, yeah, in Python list you can like insert something, but mainly everyone does append and remove like pop.
Only last element in lists.
Well, not like, but it's kind of like it.
Okay.
Okay, but here, yeah, you just add last, pop last, that's all.
Yes, this is the main purpose of the stack. You can't do anything else. You can just push and pop elements, and that's all. Sometimes in stacks you can get an access to the peak, like to the end, to the first element, for example, and sometimes, and that's all. So, yeah. Let's go to the queue. As you can see on the picture, queue is queue. Queue is a data structure which is designed to apply to the FIFO conditions, like first in, first out. So that's also pretty understandable. Here you can also see a little GIF that elements, they are going to our queue, and when we dequeue element, we release the first element, and the second element becomes the head. And that's all. So we enqueue elements to the end of the queue, and we dequeue elements from the beginning of the queue. That's all. So, and here is the same order. A, B, C, we push into the queue and we get also A, B, C in this order. Examples of queues. Print queue management. When you work in the office and a lot of people, they are printing some documents, they are putting their tasks in the queue and documents are printed in the exactly order. Customer service systems, like the first customer who came to our place, he is getting service the first, and other need to wait. And I also added a Spotify music queue as an example, because you're listening to music and you can create a queue from the songs and they will be also played in this order. So that's why we need this data structure. And realization, it's also pretty easy. So when we in queue element, we just add it to the end of the linked list. And when we dequeue element, we just get the first element and remove it and return it to get it. And it is dequeued. That's all. Thank you for attention. Maybe some questions.
Alright, so in queue, basically add last, remove first.
In queue is just add last.
In queue. It's
In queue, just
yeah.
add last.
Yeah,
But
okay.
dequeue, it's remove first. It
Oh,
doesn't
but
need.
I'm just always struggling because it's called first in, first out, but we add in the last element and like.
It was look. So you're adding the elements to the queue. I will show you.
Yeah.
You're adding first element, second, third, and when you will take them out, they will be taken out in this.
Alright, so like it's about not about like the position, but about the order of the elements, like the order but by which we added the elements, right?
Yes. So if this element was added first, so when you will call queue.dequeue, this element will be released first, and you will get.
Makes sense.
Yeah, like Spotify music, you add 10 songs and then
Yeah, I like understand the concept. I just like always struggle with the names, like first in, first out, last in, first out. Like,
Yeah, so it was first